calling it out of month. So I think if you know the top 5, give or take 1%, you're safe for the AP test. But now, I don't think the whole Earth was in your book, was it? So here they come. The top 5 for the Earth as a whole. Remember, this is the whole Earth. That includes the crust, magma, and core. The top 5 are 33% iron, 30% oxygen, 15.5 silicon. And by the way, silicon is not silicone.
It's not foods.
Yeah, so like the stuff that you use to seal sinks and to make certain types of breast implants, different from silicon. So silicon was 15.5. Magnesium is 14, and nickel is 2%. Anybody know what the Earth's core is made of? What? Yeah, mostly iron and a lot of nickel. Primarily iron and then nickel. So, now comes my question. Why is all the iron in the Earth's core? Because it's heavy? And so why is 6% of the crust iron? Would anyone like to actually make a sentence?
The spinning of the Earth is thrown it out or something? Yeah.
The terminal force is an interesting idea, but I'm pretty sure it's got nothing to do with it. Anna decided that her phone conversation is so important that she had to take her phone outside of this class to complete her cellular communication.
Ridiculous.
No, maybe it's very important. If the Earth's core is almost entirely iron, it makes up 1/3 of the total planet. How do we get 6% of our crust being iron too? A lot of kids said it's density because it's so heavy, it sinks to the Earth's core. That's mostly correct, so then why is it on the crust? Different form, maybe with an oxide. Coincidentally, most of our crust iron with an oxide was on the surface, but most of our iron as a whole in the crust has an oxide. Magnetic fields have a lot to do with iron, but in this case, I think nothing. Yes.
New deposits forming?
Yes, those are newer deposits, but how are they forming? They're not changing their elemental occurrence.
Because they just come up and like diverge back or something?
Yeah, now I'm being on it.
So the answer was volcanic activity?
Kind of. You see, look.
Well, that's just what happened more.
You be quiet. I'd like everyone to make believe for a minute. You be quiet. Everybody make believe for a minute. If you started with a purely liquid Earth, which, by the way, has happened a few times. When you hit our planet with a big enough asteroid, the energy turns all the solids into liquid for a while. So our planet has solidified, then liquefied, then solidified a few times. This happens a few times. Yeah, one of those did form the moon. Michael Bright. If the planet were pure liquid form, as it cooled, it would separate due to its density into perfect little layers. You could probably start at the top of the solids, and as you mined deeper and deeper and deeper and deeper, you would get progressively heavier and denser elements. If it were just, this was imaginary, remember, if it had just been liquid and then turned solid, it would be a perfect jawbreaker sorting all the elements and compounds into their density. But it's not just solid made from liquid. There's this constant blend of forces that reorganize those layers. You already know that the crust on the outer part of the liquid is moving, and because it's moving, things are either colliding, or rising, or sinking, or melting at the place where they overlap. Because some things rise, they're going to weather. Wind and water will disassemble them. Sediments will form, and those sediments will liquefy into a new combination of rocks that will move around and either go up or down and melt. And so the funny thing is, density is the primary explanation of those layers, but don't forget that on top of that density segregation, there are conflicting forces that mix up the elements, and geology is understanding all of those. Geology is basically knowing what those arrows mean. And different geologists will focus on different types of geology. They'll focus more on this layer, on this arrow, or on this arrow, or on that arrow. Because if you understand which ingredients are going in which directions, you might be a really good gold miner, or you might know where to look for the diamonds, or you might know where to look for the tin, or whatever. So, a couple of those arrows. Does everybody know the three different types of tectonic plate boundaries? Did this early, right? Convergent, divergent, and transform. Remember that wherever those things spread out, you get a lot of crystallization because water meets magma. And so you get a lot of cracking and things solidify, and those cracks provide a way for magma to rise out, and so you can sort interesting patterns of elements where they go like this. Also, where they go like this, you create mountain ranges, so you get erosion, you get igneous activity, stuff like volcanoes and hot spots. You get hot water rising to the surface, and that's often an interesting thing in chemistry. And by the way, a lot of my students don't know that they've been sitting next to a tectonic map. This map over here shows boundaries, and if you look on each of the plates, you'll find these little arrows like that one, and like that one, which show you the directions that all the plates are moving. It's kind of crazy to imagine that all of them are moving. Yeah?
It looks like Greenland is the same size as Africa.
Greenland's huge. I believe that this is a type of mapping which is called a projection map. So you're taking a really small part of the Earth and then you're expanding it out of scale. You realize that this square could not be shaped over a sphere, right? So at the top, that's actually exactly. So you compress all of that. Although I thought Greenland was pretty big.
It's not anywhere near the setback.
But it's not anywhere near the back. I agree. Okay. Sedimentary processes are kind of neat. Remember that as climate changes, rainfall patterns change, and as rainfall patterns change, erosion changes. So sedimentary rock often includes unusual layers during unusual climate periods. A lot of people who understand climate history apply that to sedimentary deposits For example, the water that shed off the Sierras during the last interglacial period would have a lot of gold in it. So if you can find sedimentary deposits and figure out their ages, you can often find unusual layers of sedimentary rock. Weathering is really neat. Water can weather things chemically because water is acidic and some rocks are basic. Water can also weather rocks mechanically, and so can wind. Like, anybody heard of the lizard's mouth before?
Yeah.
The mouth itself, as you know, is really pocketed. Those pockets are made by wind-blown sand. It's like sand blasting soft sedimentary rocks. You know, if you throw a brick at a stone wall, you're going to probably make a chip in either the brick or the wall. Likewise, if you're throwing sand at low-density sedimentary rock, then that's going to start to wear away at the rock. There's another cool type of mechanical weathering that happens in the Sierras where we have a lot of granite. These are called freeze-thaw cycles. Imagine this. Yeah, in a little rock, you get a little bit of water, and when that water freezes in the winter, it will expand. Then in the spring, when the ice melts, it will pour out of that crack until the next winter, when it fills up with water, it freezes and expands again. Eventually, freeze and thaw cycles can actually separate a flake from the dome, and in the spring, giant rock falls happen all over the Sierras. I have witnessed with my own eyes giant rock falls off the Glacier Point apron, off the Three Brothers rock fall, and off Half Dome. As a matter of fact, when we were there over spring break, we saw a pretty small rock fall on Half Dome. When I was talking to my best friend on the telephone, he almost died in the Three Brothers rock fall in Yosemite Valley. It was a really well-known rock fall event. It was one of the biggest rock falls ever known in Yosemite Valley.
When he almost died, or are you talking about
No, I was on the phone with him planning a climbing trip. He was in the valley, and I was going that next weekend. And I was like, yeah, man, should I bring the blah, blah, blah? And he goes, no, we got the blah, 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 but can you go to my house and grab the blah, blah, blah? And we're like, so I was like taking notes and like, yeah, so it's under your, third drawer? Second drawer? Okay, got it. And then all of a sudden you started to hear some rumbling, and then all of a sudden it gets really loud. It sounded like bombs. It was really loud. You hear people screaming everywhere, and the phone goes clang. And I'm like, buddy, Don, dude, bro, you there? Don, what happened, Don? And all I hear on the phone was this. It got louder and louder, and people were screaming. You could hear cars screeching, and a bunch of cars were renting each other right next to the payphone he was talking on. I know where that payphone is that he was using, and he could see the rock fall, and the rock fall went across a road all the way into the Merced River, and so it was a major rock fall. Anyway, he eventually got back on the phone and was like, dude, that was so gnarly. Yeah, man, I was scared. I got there a couple days later, and they still had to move all the rocks. They had to close the roads for weeks. It was really big. People were stranded in the valley for about a day. It was super, super gnarly. Those freeze-thaw cycles fuel erosion. When those big rocks fall, then of course they push stuff over and they break up bigger rocks and smaller rocks. So freeze-thaw cycles are a major part of the rock cycle in the Sierra. Anybody know what these are? Fault lines. That. This is where we take really fast cars. It's also where my mom and dad go to steal salt from Chile to bring to my house. It's really cool. This is excellent rock salt.
Can you grind it up and eat it?
Yeah.
Oh, sweet.
The way that these form is you have a river, and then tectonic uplift will trap a river. That's not an immediate process, of course. The river's like, oh dang.